Preface. This book is a thorough revision of its earlier 8th edition, which was published in 2009. That edition has served, just as the earlier ones did, as a textbook for a one-term introductory course in the theory and application of functions of a complex variable. This new edition preserves the basic content and style of the earlier ones, the first two of which were written by the late Reuel V. Churchil alone. The book has always had two main objectives. A. The first is to develop those parts of the theory that are prominent in applications of the subject. B. The second objective is to furnish an introduction to applications of residues and conformal mapping. The applications of residues include their use in evaluating real improper integrals, finding inverse Laplace transforms, and locating zeros of functions. Considerable attention is paid to the use of conformal mapping in solving boundary value problems that arise in studies of heat conduction and fluid flow. Hence, the book may be considered as a companion volume to the author's text Fourier series and boundary value problems, where another classical method for solving boundary value problems in partial differential equations is developed. The first 9 chapters of this book have, for many years, formed the basis of a 3-hour course given each term at the University of Michigan. The final 3 chapters have fewer changes and are mostly intended for self-study and reference. The classes using the book have consisted mainly of seniors concentrating in mathematics, engineering, or one of the physical sciences. Before taking the course, the students have completed at least a 3-term calculus sequence and a first course in ordinary differential equations. If mapping by elementary functions is desired earlier in the course, one can skip to Chapter 8 immediately after Chapter 3 on elementary functions, and then return to Chapter 4 on integrals. We mention here a sample of the changes in this edition, some of which were suggested by students and people teaching from the book. A number of topics have been moved from where they were. For example, although harmonic functions are still introduced in Chapter 2, harmonic conjugates have been moved to Chapter 9, where they are actually needed. Another example is the moving of the derivation of an important inequality needed in proving the fundamental theorem of algebra, Chapter 4, to Chapter 1, where related inequalities are introduced. This has the advantage of enabling the reader to concentrate on such inequalities when they are grouped together, and also of making the proof of the fundamental theorem of algebra reasonably brief and efficient, without taking the reader on a distracting side trip. The introduction to the concept of mapping in Chapter 2 is shortened somewhat in this edition, and only the mapping W equals Z2 is emphasized in that chapter. This was suggested by some users of the last edition, who felt that a detailed consideration of W equals Z squared is sufficient in Chapter 2 in order to illustrate concepts needed there. Finally, since most of the series, both Taylor and Laurent, that are found and discussed in Chapter 5 rely on the reader's familiarity with just 6 Maclaurin series, those series are now grouped together so that the reader is not forced to hunt around for them whenever they are needed in finding other series expansions. Also, Chapter 5 now contains a separate section, following Taylor's theorem, devoted entirely to series representations involving negative powers of z minus z0. Experience has shown that this is especially valuable in making the transformation from Taylor to Laurent series a natural one. This edition contains many new examples, sometimes taken from the exercises in the last edition. Quite often, the examples follow in a separate section, immediately following a section that develops the theory to be illustrated. The clarity of the presentation has been enhanced in other ways. Bold-faced letters have been used to make definitions more easily identified. The book has 15 new figures, as well as a number of existing ones that have been improved. Finally, when the proofs of theorems are unusually long, those proofs are clearly divided into parts. This happens, for instance, in the proof, section 49, of the 3-part theorem regarding the existence and use of antiderivatives. The same is true of the proof, section 51, of the Cauchy-Goursat theorem. Finally, there is a student's solutions manual, ISBN 978-007-352899-1, MHID 007-352899-4, that is available. It contains solutions of selected exercises in chapters 1 through 7, covering the material through residues. In order to accommodate as wide a range of readers as possible, there are footnotes referring to other texts that give proofs and discussions of the more delicate results from calculus and advanced calculus that are occasionally needed. A bibliography of other books on complex variables, many of which are more advanced, is provided in Appendix 1. A table of conformal transformations that are useful in applications appears in Appendix 2. As already indicated, some of the changes in this edition have been suggested by users of the earlier edition. Moreover, in the preparation of this new edition, continual interest and support has been provided by a variety of other people, especially the staff at McGraw-Hill and my wife, Jacqueline Reed Brown.